Hey everybody, so in this video we're going to talk about the section 2.5 from modeling functions and graphs, and it has to do with absolute value. Okay, so the thing that you should already know about absolute value is how to evaluate the absolute value. So let's review that. Okay, so the absolute value of a number is related to its magnitude, right? It doesn't have to do with direction. So we know that the absolute value is the magnitude of 1 or 1, okay? And it will be the same for -1. It's just the magnitude, so it's 1, okay? Sometimes, let's do a couple more examples of this. You might have some number that's a little bit less normal, something like this, okay? You still evaluate the absolute value exactly the same, okay? So this would still be 1/4, okay? And this would still be √2, okay? All the absolute value does is tell you the magnitude and disregard the direction, okay? And the last one I want to talk about is the absolute value of 0. Sometimes students can't think about what this should be, but it is 0. Okay, the magnitude of 0 is still 0. Okay, so let's look at the formal definition of the absolute value. Okay, so the definition of absolute value is the distance between that number and 1. Okay, so this is one reason that you'll see the absolute value is always positive, because a distance is always positive, right? And distance also doesn't indicate direction. So it doesn't indicate if the number is 1 unit to the right, like this, or 1 unit to the left, like this. They are both the same distance from 0. Okay? All right, so what we're going to do with absolute value and with this definition is we're going to look at some absolute value equations and how to solve them. Okay, so first let's look at an equation like this. Okay, so we have a number whose absolute value is 3. Okay, so we're going to look at the number line. Okay, so if the absolute value is 3, then the distance from 0 to that number is 3. So we're looking 1, 2, 3 units away. So that means that this number could be 3. Okay, but absolute value doesn't tell you the direction. So we could also be going 3 units to the left, 1, 2, 3, which would mean that this number is -3. Okay. And you can check using your knowledge of absolute value that both 3 and -3 do have absolute value 3. Okay. So let's look at another example like this. Okay. All right, so this number in here, the whole thing as a single unit, is 1 unit away from 0. So it could be 1 unit to the right, meaning that that whole expression is 1, or it's 1 unit to the left, meaning that whole expression is -1. okay? Then we can solve for x by subtracting 1 here. So we would get x equals 0 or x equals -2. Okay, so you can see that for these types of equations, we're normally going to get two solutions, okay? But they're not always plus and minus the same number, okay? All right, let's look at a slightly more complicated example. Okay, so the first thing that we can see that's the difference between this example and the previous example is that we have this stuff outside of the absolute value here, okay? So the first thing we're going to do is isolate the absolute value. Okay, so we're going to do that by first subtracting 7 from both sides. Okay, and then dividing both sides by -2. Okay, and now we're in the same situation that we were in our previous example. Okay, so we have this expression that is 1 unit away from 0. Okay, so remember, we're considering the whole expression as a single thing. So this whole thing is one number, okay? So this one number might be 1 unit to the right, meaning that 3x minus 1 would be 1, okay? Or this number could be 1 unit to the left, meaning that this whole expression 3x minus 1 is -1, okay? And then we can solve both of these equations normally. So this would give me 3x equals 2, so x equals 2/3, okay? Or here I get 3x equals 0, so x equals 0. Okay. Let's try one more like this. Okay, so we're going to do the same thing. We're going to isolate the absolute value. First, we're going to add 10 to both sides. And then we're going to divide both sides by 2. Okay, so now we're talking about this expression as a single number. Okay, so this number is 3 units away from 0. Okay, so if that number is 3 units to the right, okay, then we know that that number is 3. Okay, if that number is 3 units to the left, then we know that that number is -3. Okay, and we can solve each one of these by subtracting 4. Okay. All right. So these are kind of the base examples of absolute value equations. Okay. So let's look at a couple of unusual examples. Okay. All right, so we're going to do the same thing that we did in the previous example. We're going to subtract 2 from both sides. to isolate the absolute value, and then we're going to divide both sides by 2. Okay. Now that we have the absolute value isolated, okay, remember we're thinking about this expression as a single number. Well, that number is 0 units away from 0. Okay. Well, if that number is 0 units away from 0, it's right there on the number line, meaning this number has to be 0. Okay. And this is unusual because we're only getting a single solution. Okay. And this only happens with 0 because 0 is the only number who doesn't share its absolute value with its other number. Okay. So like 1, -1, 1/4, -1/4, they share absolute value because they're the same distance on the either side of 0. But here, there's no number on the either side because they're exactly at 0. So in this case, you will only get one solution. Okay. Let's look at one more unusual example. Okay. So again, we're going to isolate the absolute value. So first we're going to subtract 7 from both sides. Okay. And then we're going to divide both sides by 2. Okay. Now let's think about this. The absolute value is a distance. So can a distance be equal to a negative number? It can't, right? A distance is always 0 or positive, right? There is no such thing as a negative distance. So let's summarize this, right? This is impossible since absolute value is a distance and can't be negative. Okay, so what does that mean for our equation? Well, if this is impossible, then that means that our equation has no solutions. Okay. All right. So these are kind of the two more unusual cases that you can run into, okay, where either you only get one solution like this, or you get no solutions, as opposed to the normal type of equation where you'll get 2 different solutions. Okay. Let's look at another type of absolute value equation. Okay, where we actually have 2 different absolute values. Okay, so when you're solving this, there's 2 different things that can happen. Okay, either the absolute values are the same because the numbers are the same, or the absolute values are the same because the magnitude is the same, but the signs are different. Okay, so one possibility is that these 2 expressions are just equal to one another. Okay, If these two are equal, then certainly their absolute values will be equal. Okay, so this is one source of solutions for this equation. Okay, the other possibility is that they're almost the same, okay, but one of them is negative and one of them is positive, okay? So they only differ by a negative sign, okay? Now these would still lead to them having the same absolute value, right? Because absolute value ignores the negative sign, okay? So these are the two different possibilities that come from having these two expressions be equal. Okay, so let's go ahead and solve these. I'm going to subtract x from both sides, and then I'm going to subtract 1 from both sides. Okay, so here's one solution. Over here, I'm going to distribute my negative sign. Okay, I'm going to add x to both sides. Subtract 1 from both sides, and then divide both sides by 3. Okay, so there I have my two different solutions. Okay, let's look at another example like that. Okay, so again, there's two possibilities. Either these two expressions are exactly the same, okay, or these two expressions differ by a negative sign. Okay, so over here, I'm going to solve this by going ahead and multiplying both sides by 3. Okay, so on the left, I would get 3x minus 9, okay, and over here, this 3 in the denominator is going to cancel with this 3 in the numerator, which was my plan, okay, so that I have no fractions left, okay. Subtract x from both sides, add 9 to both sides, okay, and then divide both sides by 2. Okay. Now over here, I'm going to use pretty much the same plan, but first I'm going to distribute my negative sign. So this is going to give me negative x minus 2 over 3. Okay. Then I'm going to multiply by 3 to cancel this denominator. Okay. So on the left, again, I have 3x minus 9. Okay, and over here, these are canceling, and I have minus x minus 2. Okay, so I'm going to add x to both sides, and then add 9 to both sides, and divide both sides by 4. Okay, and there's my two solutions for this equation. Okay, these are all of the possibilities really for absolute value equations. Okay, so in the next video on this section, we're going to talk about absolute value inequalities. So I will see you guys soon.